Sorry guys, we got cut off there. So here's what I was saying. In the change of base, if we start with b to the log base b of a, that should just come out to be a. And now what I'm going to do is I'm going to take log base c of both sides. So I'm going to get log base c of b to the log base b of a equals log base c of a. So all I've done is there's that side and there's that side. So all that happened was I added a log base c out front. And then here's something really cool that happens. Since I just proved that when you have log base b of anything to a power, that power pulls down in front and it sits right there. So now there's my power. That should pull down in front. So what I get is log base b of a times log base c of b equals log base c of a. To finish it, all I have to do is divide both sides by log base c of b. Those cancel, and I'm left with log base b of a is log base c of a over log base c of b. And here's how I remembered it. Nobody told me this, but when I was a student at college, I figured this out. Whenever we write the log, this always sits lower than this. And so I remembered that the change of base, somehow you start with a regular log and it turns into a fraction. Notice all of these, any way you slice it, they're a fraction. And so if you drew a fraction bar right between the log, the a sits up top and it stays up top. And the b is down low and the b stays down low. And all you have to do is put log c, whatever your favorite number is, on the other side. So that's how I remember it. I'm going to show you a couple cool things right now in the calculator, and then we'll switch to the problems, okay? So here is a few really kind of neat things that you can see how it comes to play. Log base 2 of 16 should equal 4. And the reason for that is because 2 to the 4th power is 16. So we should all know that 2 to the 4th is 16. And so that's a true statement. But if I had a calculator such as this, notice, and this is kind of weird because I can't use that laser pointer anymore, but right to the left of the number 7 key, it says log. And to the left of the number 4 key, it says ln. Those are only for log base 10 and log base e, the natural log. This calculator does not have a different base. And so, for that reason, you have to do change of base in this. And so, if I wanted to figure out what this was, and let's say I didn't know that, so I wanted to know what that was, I could change the base in this, and I could say, well, that's log 10 of 16 divided by log 10 of 2. So let's try and play that out in this calculator. So I'm going to say log 10 of 16 in parentheses. So log of 16, and then divided by log of 2. If you look, that answer is 4. And so what we've done, but that's what we already said it was, because we knew 2 to the 4th would be 16. I could also say this, though. I could say it's ln 16 over ln 2. So I'm just changing the base. Instead of base 10, it's base e. Let's try that. ln 16 divided by ln of 2 is also 4. And so it doesn't matter what base you change it to. These two things are equivalent. Always, no matter what base you have. I'm going to try something, and I don't know if this works. So bear with me for 1 sec. I think in the math menu, there is. So if I go down here to option A, it has log base. And if I use that command, now I'm going to just change it to any other base that I want. So if we were in class, I would let you guys pick, but I'm going to pick for us. So I'm thinking 11. For whatever reason, I like the number 11 right now. And so I could say this is log base 11 of 16 divided by log base 11 of 2. Let's see if that works also. Go to the calculator. Log base 11, not 111, but 11 of 16 divided by math, go to A, log base 11 of 2. It's also 4. So in these three lines, the top one we're in base 10, the second one or middle line we're in base E, and the bottom one we're in base 11. And so, but it doesn't matter. All of those represent log base 2 of 16. And that answer any day of the week is 4 because 2 to the 4th power is 16. So that right there shows you the change of base formula in action. And it's very, very useful, especially if you don't have a calculator that has a log with a different base feature. Most calculators only have base 10 and base E. One final thing I want to show you, and I'm just going to combine a few of the problems or properties together because this makes doing the homework way easier. And so I'm going to take something like this. Log base, I'm going to just call it log base x of a times b times c over d times e times f. And so what would this turn out to be? I'm going to show you right now how easy this is and what the answer is just by writing it down. This is log base x of a plus log base x of b plus log base x of c minus log base x of d minus log base x of e minus log base x of f. And so the moral of this story is, notice the a, the b, and the c are in the numerator of this fraction. From the properties, over here, whenever you have things up top, they get pluses out front. Things that are on bottom get minuses out front. And so these three things are on top in the numerator. They all have pluses in front of them. These three things are on the bottom, and notice they each have a minus in front of them. Let's see why that's actually true. In order to really derive that and see that it's valid, I'm going to start with log base x of a times b times c over d times e times f. And first rule I'm going to use is this subtraction rule because I have a quotient in there. And so when I come back, this should be log base x of a times b times c minus log base x of d times e times f. Well, that doesn't look like this yet, and so we're not done yet. Now I'm going to come back here and use this first property. The first property only shows it for 2, but if I had 3, I could add a p in there, and then I'd have a p there. But then this, since it would have an n and a p in it, by this very rule, would become another log base b of p. And so if there was 3 pieces in there, you would just get another summoned in that formula. So back to this then. These pieces right here should get pluses because that's all multiplication in there. So we have log base x of a plus log base x of b plus log base x of c. Now we have a minus, but this also is a product in there. It's d times e times f. And so that is going to turn into addition by this rule. But the entire thing has a subtraction out front, so I have to add parentheses. So I'm going to put parentheses, and now I'm going to use that property and say that's log base x of d plus log base x of e plus log base x of f. And if you notice, I have pluses in here, but in the formula we have minuses. But that's because this minus distributes to those three pieces. So in the end, we get log base x of a plus log base x of b plus log base x of c minus log base x of d minus log base x of e minus log base x of f. So there you have it. Why do I show that to you? Because here's the types of homework problems that you are going to encounter. It will say expand as much as possible. And here's what they mean. They'll give you something like log base 2 of x cubed times y to the fifth over the square root of z. And so I have to take this and somehow expand it out. Well, that's why I just showed you guys this rule right here. So anything on the top turns out to have pluses, and anything on the bottom turns out to have minuses in front of them. That means in this example, I can say this is log base 2 of x cubed plus log base 2 of y to the fifth. And now since that square root of z is on bottom, that's going to get a minus log base 2 of the square root of z. And here's a couple things I'm going to say just to remind you of. Those powers pull down, so I'm going to pull those powers down for sure. This, though, is a square root, but the square root actually is a power. Remember, the square root of a is actually a to the 1/2 power. So when you have fractional exponents, the denominator is the index of that root. Actually, you learn it as a to the n over m is the mth root of a to the nth power. And so I am going to change. Normally, I would write the step out again, but I'm going to write the whole thing just to make that radical sign into a 1/2 exponent. So there you've seen what I've done. I've told it to you, and so please know that the square root turned into the 1/2 power, and I'm doing that, my friends, because I'm getting ready to use that third property and drop all of those powers like they're hot. So we have 3 log base 2 of x plus 5 log base 2 of y minus 1/2 log base 2 of z. And that, my friends, is as much as I can expand it. There's nothing else inside but a single piece, a single piece, a single piece. I have all of the exponents down in front, and now they're just multipliers. And so this is expanded as much as possible. Notice, though, here's the really cool thing. That x cubed is on top, so it should have a plus, but that 3 would pull down. There it is right there. The y to the fifth is on top, and so it should have a plus, but that 5 would pull down, and so we should have 5 log 2 of y. That's right there. And this is a z to the 1/2 power. It's on bottom, so it should get a minus, and the 1/2 will pull down front, so it should be a minus 1/2, and there it is right there. So let's go to the problems. Here's what they look like. So as promised, here is what we get. And I'm just going to go through and write on here. So I'm going to do problem number 4. Look at problem 4. Problem 4, the first thing I see that I can do is I can multiply the 3 times 5 in there. And I can say this is ln of 15 a, b, c. Now I have 1, 2, 3, 4 things multiplied. And so if I expanded it out, I could say that's ln 15 plus ln a plus ln b plus ln c. And that right there is expanded as much as I possibly can get it. If we did something like problem 6, or problem 6 right here, In this, I'm going to think of this as the top part and this as the bottom part. And so, in that case, since this is on top, I should get a log 4 of x over z minus log 4 of w. But this now is a quotient, so it becomes subtraction. So this should be log base 4 of x minus log base 4 of z minus log base 4 of w. All right, so that took a couple steps to get there. We used that we had one fraction that had a fraction as the numerator and a single variable as the denominator. That's what we call a compound fraction. And so I wrote it out by just doing log of that minus log of that. That's right there. Then I investigated that that was another quotient, and so as such, it becomes subtraction right there. Here's something that we could have done, and it would have made it a lot easier, you guys. Watch this. I'm going to erase that. Remember the answer that we got? Here's the deal. X over z all over w. If I just put that w over 1, then we're just dividing fractions. And the way we divide fractions is to use Missy Elliott and say, is that problem worth it? Let me work it. I'll put my thing down, flip it, and reverse it. So reversing division will reverse it to multiplication. You know, you just flip and multiply to multiply fractions. And then how do we actually multiply fractions? We go straight across the top. I get x, and then straight across the bottom, I get zw. So this really is log base 4 of x over zw. Now using what we just talked about over here with this big long thing, I can see very easily that the x is on top, so it should be log 4 of x. The z's on bottom, minus log 4 of z. The w's on bottom, minus log base 4 of w. And that, if you rewind the video because I erased it, that's the exact same answer we had. So we could have got it by using algebra and simplifying that compound fraction to begin with, and then just apply the rules to that single fraction. Or the first way I did it, we did that as the numerator, that as the denominator, and then we had to take an extra step to get through it. On this right here, the only thing I could see to do would be to take that x and pull it down, and so this would be x log base 2 of y, and there's nothing else I could do. So that's how you do the properties on those types of problems. Notice then in the second set, all that says is go back the other way. That's all you have to do is just take this back in reverse. And so in problem 10, if you look, I have nothing but a bunch of summons. And in the properties of logs, when you have stuff added together, it becomes a product within the log. And so if I did this, it should be, if I did it real slow, you guys, here's what it would be. It would be log base 3 of 2a plus log 3 of 11 plus log 3 of b. And the reason for that is because this rule technically only works for 2 logs added together. So then 2 logs, you can put the m and the n together inside. So what I've done here is I took the 2 and the a and put it together inside. But I just left that and left that. They're right there still. Now I can take this and count those as 2 logs, use this property, and go back. And what I would say then is this is log 3 of, it's 2a times 11, but 2 times 11 is 22. So it's 22a, but then I would have plus log 3 of b. Now this is a final addition of logs problem. And so I would then multiply one last time and get log base 3 of 22 times A times B. That would be the final answer to that. The other problems in here, same thing. You know that's going to turn into a fraction. But this, it's easier almost if you just remember that little trick that I showed you over here. This trick right here. That things up top wind up with pluses and things on bottom wind up with minuses. If we take this problem here in problem 12, then very simply I could say, well, it's going to be an ln. The A is positive. There's a plus out in front of that, so there must be an A on top. But there's a minus on the D, so there must be a D on bottom. Oh, and there's a minus on the C, so there must be a C on bottom. You guys, that's the answer to problem 12. This in here, it's the same thing. You're going to use all the properties, though. So there are powers this time. In this case, you would say, well, that's ln of a to the negative 2. Because it's on top, there's a plus out front. The b is on bottom, so it should have a minus ln of b to the minus 4. And the c to the 5th power is on bottom too, so it should be minus ln of c to the 5th. But then, hold on, I'm going to actually cut this and take it because I want to show you a few things that are really cool about this. So it's a to the negative, okay. So it is ln a to the negative 2 over b to the negative 4, c to the 5. Is that right? Yep. Okay, so here's where we were. I said this would be ln of a to the negative 2 minus ln of b to the negative 4 minus ln of c to the 5th. Now each of those powers pull down, so that negative 2 pulls down, the negative 4 pulls down, and the 5 pulls down. The negative 2 would make it minus 2 ln a. A minus minus 4 makes it plus 4 ln b. And then we have minus 5 ln c. So that would be as simplified as I could get it using just straight properties. But here's the thing. You guys do know that negative powers in the numerator, negative exponents, become positive if you take them to the denominator. And negative exponents in the denominator become positive if you bring them to the numerator. So if I would have at first said, no, that b to the 4 can go up top, that a squared should be on bottom, and that c to the 5th can stay down. Fine. Then I could say the b to the 4th's on top, so it should be ln of b to the 4th, but the 4, you know, by now is going to pull down. So it should be 4 ln of b, and then the a squared is on bottom, so it should be a minus, but the 2 is going to pull down, so minus 2 ln a. And the c to the 5th's on bottom, so it should get a minus, and the 5's going to pull down, should be a minus 5 ln c. Here's the thing. 4 ln b matches 4 ln b. Minus 2 ln a matches minus 2 ln a. Minus 5 ln c matches minus 5 ln c. The fundamental difference above and below this red laser line is up here, I only use the properties, and I use them exactly the way that they were intended based on the way the problem was given. That's in the numerator, it gets a plus out front. That's in the denominator, a minus out front, and the same with that one. In this bottom one, I instead rearranged, used properties of exponents, made all my exponents positive, and lo and behold, the answers came out to be identical. So that is how you play with those. In these, it says rewrite each into an equivalent base. If you wanted base E in there, then you know it should be ln 15 over ln 7. That's my little draw your fraction bar in there. And base E, log base e is ln. So that's how you do that. In these, it says rewrite. Suppose that you know log 5 of 6 is a, log 5 of 11 is b. Use change of base formulas and all of that stuff. So if I was going to do something in, let's say we're going to do like 27. So log 11 of 5 would be the same as, here, let's do this one. This one will illustrate it much better. So what I'm going to do is first use nothing but the properties. The properties in here say that I have a quotient, and so I should get log base 11 of 6 minus log base 11 of 11. And now what I know is that log base 11 of 6 is supposed to be different. These are messed up. Don't worry about those right now. In these, though, I can show you these. Let me see. Yeah, these look good. All right. In 30, this is log base 3, and 1/9 is 1 over 3 squared. Minus 3 log 3 of 3. One thing that you do need to know is log base b of b is always 1 for any b. Why is that true? Because by that counterclockwise formula, it says b to the first power is b. And isn't that true that b to the first power is always b? So anytime the b down there matches the b right there, the answer is 1. And so look, I have log 3 of 3 right here. And so because I have that, this should be just 1 right here. And I can then use the properties of exponents to bring this up to the top. And watch what we get. So I'm going to have log base 3 of 3 to the negative 2 minus 3. And if I bring that minus 2 down, it'll sit out front, and I will get minus 2 log 3 of 3 minus 3. And log 3 of 3 is 1 because that 3 matches that 3 right there. So the answer actually is negative 2 minus 3. It's negative 5. So I can show you that. Answer, it's negative 5. So we could figure that out just using those properties. So that should be enough to get you guys through the problems. Like I said, have fun with it and do your best. Make sure you know the properties. There is another property in the book that you may need, and it deals with switching them. I don't know if I can find it. Yeah, there's the power rule. They don't have it. So don't worry about the last rule I'm talking about. We can get through all the other problems with just the rules I gave you. All right, hang in there, guys. Take care. I'll talk to you soon. Bye-bye.